All right. Regression. Again, the distinction between correlation and regression is that a regression allows us to make a much more powerful statement about the relationship between the variable or variables. It allows us to predict from one variable to another. Now, your text talks about, okay, let me go ahead and get it set up. Analyze regression linear. All right. Our dependent variable is what here? Math achievement test. And our independent variable, excuse me, is grades in high school. Grades in high school. Where is it? Where is it? Here we go. Okay. So what we're saying here is that we are about to examine the degree to which grades in high school predicts math achievement. That's what we're about to say. Okay. Now let's take a look at the output. It's a little bit to look at, more than you're used to, and that's okay. Let's go through the most important points, some of which we'll discuss in class, especially the portion about the regression equation. Here we have dependent variable, math achievement test. Variables entered into the equation, grades in high school. Important, adjusted R-squared tells us that grades in high school explains 24%, over 24% of the variance in math achievement. And what does that mean? Math achievement test, rather. What does that mean? That essentially says that it's a measure of influence. So the higher this value, the greater influence our independent variable has on our dependent variable. So 24% of the variance, the change in math achievement test, is explained by grades in high school. All right. This is perhaps the most important value here. This tells us that this is a significant regression relationship, a significant regression equation. Anything less than 0.05 in statistics, generally speaking, is significant, which means that this outcome would happen less than 5 out of 100 times by chance. Okay, so that's sufficient for us to say, wow, that there's something here to really consider. All right, now in SPSS, when you see 0.000, that doesn't mean that there's no value there at all. It's just an indication that the value is less than 0.000 something. So if I double click on it, you will see this -6 here indicates that I should move this decimal place over 6 times to get the exact value. So it's like 0.000004, something like that. but for our purposes, it's sufficient for us to understand that if this table, this ANOVA table, is less than 0.05, the significance is less than 0.05, then there's a significant regression relationship. Okay, again, the amount of variance, percentage of variance explained. Okay, we're going to multiply this by 100. Going to boop, boop, move that over 2 places. More than 24% of the variance in our dependent variable is explained by our independent variable. Adjusted R-squared is important. Significant is important. Hey, if this wasn't less than 0.05, we wouldn't even be talking about it. Okay, but it's less than 0.05, so this is a significant regression relationship. And here is where we would start to construct our regression equation, our formula, where we can predict one value from another value, but we will do this in class. Okay, regression. Take a look at it, work on it. All right, regression. Next is multiple regression.